All right, I'm just gonna record this for you. Some of you obviously need help on it. Okay. All right. So, if you know how to do this, you can skip this video. But if you don't know how to do it, I guess just follow along. Okay. So, exponential growth. So here's an example that has exponential growth. So, certain stock opens with a price of 59 cents. First couple of days, the value of the stock increases by 50% per day. If this trend continues, how many days will it take for the stock to be worth $6? Okay, so there's three formulas that I presented to you. One was represented growth, decay, and the other one was for continuously compounded interest. Don't worry about the compounded interest one. This one is on exponential growth. So the formula for exponential growth is going to be f of t equals a times 1 plus r, and then raised to the t. Okay, so if you don't know what those parameters are, please look in Google Classroom in my notes for that. Okay, so A represents the initial price. So the stock opens with a price of 59 cents. That's your initial value. A equals 0.59, so 59 cents. Over the first couple days, value of the stock increases by on an average by 50% per day. So 50% per day, that's our rate. R is 50%. We need to convert that percent into a decimal. 50 divided by 100. That's going to be 0.5. Okay. Next, it says if this trend continues, we want to find out how many days it takes for the stock to be worth $6. So $6 in this case, that's our output. That's f of t. F of t is our final value. So f of t is going to be $6. Okay, so this is really easy. All I gotta do is just plug in all the parameters into the equation. So 6. So I'm just taking that the formula from up here. So this is f of t is 6 equals a is 0.59, and then 1 plus, and then our rate is 0.5, and we're raising it to the power of t. Now, again, what I mentioned in class for you guys was some of you can't answer this without by hand, by understanding logarithms. But the way we can get around this is we can graph these functions. So we can graph y equals 6, which is this on the left hand side here. We can also graph y equals this whole thing here. So this whole thing, that is our equation for exponential growth. We also know this is exponential growth because 1 plus 0.5 is 1.5. So if you see that there, it's exponential growth. If you guys were paying attention right before the quarter ended, if this number in the parentheses is greater than 1, that represents exponential growth. Okay, next, what we need to do is we need to graph these functions on Desmos. Okay, so I'm going to go desmos.com/calculator. All right, so I'm just going to graph those two functions. So we have y equals 6. I'm going to graph that. So y equals 6. Next function we have to graph is this function. So y equals 0.59 times 1.5, and we're raising it to the power of t. If you guys forgot how to do that, this here, you have this to get the exponential notation. You need to press Shift 6. Shift 6 gives you the caret. That's how you graph it. Now, what I see here is we can go ahead and see where our point of intersection is. So you can use this plus and minus to zoom in and out of Desmos. Just click on the intersection point. So this intersection point, this intersection point, this is the first value is t, the second value is y. So this means in this context, this 5.72, that's our value for time. That's how many days it takes for the stock to reach $6 from 59 cents. So if you wanted to just write the answer, it would just be it takes what was it again? 5.72 days for the stock to reach $6. That's it. And that's your answer. You can just highlight that so you can see that. Okay. All right. So next one. There's a here's exponential decay. Right, so value of a truck purchased new for $28,000, decreased by 9.5% each year. After how many years would the value of the truck be $5,000? Exponential decay is basically the same formula as the other one. The only difference is exponential decay, instead of a plus here, we have a minus. So it goes 1 minus r, and then raising it to the power of t. Same pattern. So value of truck purchased new. New, that means that's our original value. A is equal to $28,000. That's how much the truck started off. That's how much it cost to begin with. The value of the truck decreases by 9.5% each year. So this means R equals 9.5%. So this is this part here. We're dividing that by 100 because we need to write this as a decimal. 0.095. Next, it says we want to find how many years it takes for the value of the truck to reach $5,000. This is our final value. So f of t equals 5,000. So all we're doing is we take that same equation from up here. We're taking the same equation and we're just plugging it in. F of t is 5,000. A is 28,000. R is 0.095. And then from here you can just graph y equals 5,000 and y equals this whole thing, 28,000 times whatever that is. Now you could go ahead and simplify this part if you wanted to, right? So 1 minus 0.095, I'm using the calculator on my phone right now. This is going to be 0.905. Okay, so what you're doing is you would have to graph this function and this function. So y equals 5,000, and you have to graph the other one. So y equals 2,800, 28,000 times 0.905, and raising it to the power of t. Okay. So as you see here, some of you see there's no graph. So that's why you have to use this zoom in, zoom out feature. You have to zoom all the way out. You have to zoom, sorry, that's my dog. That's my crazy dog. Just keeps barking. Just ignore him. But you just gotta scroll in. You scroll in here. And that represents our solution to the this expression. So what we know here is, in the context of this problem, let's see, it says how many years would the value of the truck be? $5,000. So that means it takes about 17.2, it says nearest hundredth. So we're going to say that it takes about 17.26 years for the value of the truck to reach $5,000. So that's basically how you would answer that problem. Okay, last one. Okay, so this one, continued compounded interest. All right, so a person invests 5,000 in an account that earns 3.5% annual interest compounded continuously. Okay, find when the value of the investment reaches $12,000. All right, so what we have here is we have another formula. So v of t equals p e, and then we're raising it to the rt. Okay, so what we want to do is so I can just tell you what these parameters are if you guys remember from compounded interest. P is your initial value, that's how much you start off with in an account. R and T, that's your rate, that's your time. And then V of T is the value or your final amount that you have left in the account after so many years. Okay, so person invests $5,000. So since you're investing $5,000, P equals 5,000. Okay, in an account that earns 3.5% annual interest compounded continuously. Compounded continuously basically means we don't have to worry about, like in class we mentioned